Hello. Hi. It's the afternoon. If you can hear me, raise your hand. Okay, great. Thank you. I love being the presenters for like, you can't hear me. Raise your hand. Purpose. So thank you for coming. I appreciate your time today. I'm really excited to be here because I get to share with you some of the cool stuff that I'm doing, and I get to share with you kind of what's going on in the world of education, especially when it comes to iOS. So I wanted to just introduce myself and tell you where is the state of education. There's so much movement and interest in going on with iOS, specifically in classrooms. And what are people actually learning is usually the biggest question. You get this, oh, kids are learning coding. And you look over their shoulder and they're doing block-based coding with a little cat. And you're like, well, I'm not really coding. So we're going to talk about that today. So I'll give you some insight to that. And if I block the screen, please tell me because I do tend to wander. So if I end up standing here, just someone wave me down. Okay. So my name is Jessi Charier. For those of you who know David Charier, yes, that is my husband. I got into the field of iOS development and just all things tech because of him. And I started as a classroom teacher. And so my trajectory kind of took me down a strange path where I eventually became head of education at Mobile Makers Academy. Some of you may have heard of them. They started as a boot camp where we were training adults to convert into becoming iOS developers. And we got so good at our job that we had local high schools saying, hey, we send our teachers through your program so they can take that back to their students. And when we looked at our mission and we discovered that the whole goal was to provide as much opportunity as possible to as many people as possible, it made more sense for us to teach teachers iOS development so they could take it back and hit thousands than it was for us to just hit 100. So that's kind of who I am and kind of where we go. So this is what coding looks like from our perspective, or at least the result of it. It has very little to do with our goal in making sure that their syntax is right. Our goal and what we see in regards to coding is providing opportunity and being able to provide solutions, giving students the ability to provide solutions for themselves. So these girls were taught over the summer, just this past summer, and they had created 2 apps. One was about being able to vet hair extensions for the African American community. And then another one was a social media group about Black Lives Matter that they then took back into their neighborhood and started to create community with. So where is all this coming from? How many of you heard of coding in the classroom? Like how many of you are here because you're interested in like what's going on in the classroom? Great to see everybody's hand go up, or at least most people. So what is actually going on in the classroom and why is there buzz right now about this coding in the classrooms? Well, a couple years ago, we got this statistic tossed at us in the education space that was a little sensational, but it was interesting for us to read. For those of you who may not be able to read it in the back, it says that 1 million jobs in computer science or computer-related field will go unfilled by 2020. This statistic came from the Bureau of Labor and Statistics saying that we're short developers, and so the education community responded and said, snap, we need to do something about this. So the problem is, though, that there's less than 25% of schools actually offer any kind of coding or computer science in their classes. Much of this, everyone take a guess as to why so few do.
I would say money.
Money is definitely one of it.
Lack of instructors.
Lack of instructors is the key reason. Usually, if someone goes through to become a CS degree, they often don't return to the classroom. When you can make twice the salary out in the field, it's really tough. Very few people return to the classroom. And currently, a lot of states require you to have a CS degree to teach a computer science class. So we want all of these opportunities to be presented to our students, but we don't have enough teachers to actually do it. So that's one of the reasons that we come in is that, and one of the reasons we don't teach students, we teach teachers, because we have experience in taking someone who has no coding experience into the world of iOS. We can take a teacher with no coding experience and make them a coding teacher. So that's where we focus our energies. There were some other things that people started to do too in the field of education. This is just for some backdrop. Barack Obama came out with the CS for All initiative, which put a huge fire under the tails of a lot of companies and a lot of money. We also have about 25 states now can accept computer science as a graduation requirement. Up until now, like within the past 2 years, it was considered an elective. And was often put in the back corner with like something much more vocational, but a lot of people didn't know where the computer science classroom was. So it was often seen as an elective, and now it's seen as more of a requirement. In fact, CPS, for example, Chicago Public Schools, requires it now for graduation. The state of Virginia requires all of their high school graduates to have a computer science class. So there's all this push for computer science. The best part about this, though, is when I talk to administrators, they come up to me and they're like, yes, we need computer science. I go, great. What does that mean to you? What is the definition of computer science? They go, I have no idea. I think it has to do with IT and networking. I'm like, great. Have you heard of this thing called coding? And they're like, isn't that the same thing? No, it's not. So trying to help reframe and reteach the administration and education space on what is coding, what is IT, what is networking, all of these different facets of the field. So I'm going to focus on coding specifically, and I'm going to focus specifically on iOS and some of the other stuff too, so you can see the landscape. So they're taking these coding classes, these computer science classes. What are they actually learning? There are usually 3 courses that a school, usually a high school level, will offer. If you're lucky, you get an intro to programming class. Otherwise, you can take 1 of 2 AP computer science classes, computer science principles, or computer science A. Intro to programming is usually HTML. At best, it's usually HTML. Once in a while, I'll meet someone who does PHP, but usually it's an HTML or CSS. It's more of a scripting language than it is programming. AP Computer Science Principles, out of the entire year, they have 7 units they have to cover. 1 of them is programming. And out of that 1 unit, there is 1 learning outcome that says that they will be able to build an app. That's it. And it's very small in scope. So the access, even there at an AP college level, to learn to develop working applications for working devices is very, very minimal. AP Computer Science A is a forced language in Java. And the reason that students have to learn it in Java is because that's what the test is in. So the AP test is in Java. The reason the AP test is in Java is because the College Board says that that's what they teach at the college level. And the college level says that's what the enterprise needs. And the rest of the market goes, why? Why would you subject someone to Java as their first language?
Could be worse.
It could be worse, but there are so many other options out there, especially now, right? And I'm not saying that iOS is the panacea to everything. It's definitely not, but Swift is such a great language to learn in because it's an easy entry point and it can scale pretty quickly. In regards to the depth, there's like no glass ceilings for it. There's bugs, things break, but you can build out some pretty sophisticated stuff with Swift. So what I wanted to show you though, one of the big questions that I get from developers are, well, what are the real skill sets that students are leaving these classes with, okay? So I want to make sure that I give credit to that. So the CS Principles class, you'll notice that there are 7, like I said, 7 units. 1 of them is programming. The rest of them are all theory-based. They don't even have to touch a computer, okay? I will give you a little bit more detail into this as well, but let me kind of walk you through what some of these are. Creativity is focusing on how can computers be used in a way to solve problems creatively. So theory-based creativity. Abstraction is also the same, it's very theory-based abstraction. What are the different forms of abstraction? What are the pros and cons of the different forms of abstraction? Same with algorithms. Here are 15 very common algorithms for sorting through an array. Memorize them all. Okay? The data and information is not as heavy as you think it is. It's much more of a, why is data and information privacy something that's important? How do you manage data from a user and developer standpoint? The algorithms, like I said, was that. Programming is more of a problem-solving capability. So again, even within that section, everything can be done outside of the computer, so it's all if statements. It's more, again, all theory. And then the internet. I love that name of that title, the internet. We're just going to do a unit on the internet. The internet literally talks about what is the history of the internet and how does it change the world. And then global impact. How does this impact the world? It's very altruistic, and I love the fact that that's the direction that they're trying to go, is to help students understand the impact, social impact. But if you have a student that just wants to code, this is the worst class in the world. because it's all theory. They don't actually get their fingers into the code. So I'm not going to belabor this, but here are just some, if you are interested, you can also find this online at AP College Board. These are some of the driving questions for some of them. And there's a repeat in the abstraction, I apologize for that. How can computational models and simulations help generate new understanding and knowledge? That's huge. That's huge. And if you have a kid who's never even coded, how can they answer that with any real ability to be able to drive that in? They could talk at it at a high level, but really when it gets down to the nitty-gritty. Why are some languages better than others to use to implement algorithms? They haven't even been introduced to multiple languages yet. So like there's all this really great stuff in here, but again, they're missing the piece of being able to get your fingers on the code. And then there's other programming. Oh, here's the programming one. How do computer programs implement algorithms? How do people develop and test computer programs? What mathematical and logical concepts are fundamental to computer programming? They're all good questions, but the students don't walk out with an app. So that means because there's no specific language that has to be taught for an AP college credit CS class, some students are being taught this class in Scratch, which is fine. There's nothing wrong with Scratch, especially to initially learn. I'm totally a fan of Scratch when you're starting to learn, so I don't want to ever sound like I'm dissing this. This is a great starting point. But when students can't take this home, and it's bound by the laws of being able to have a browser and being on that computer with that login at that school, you are stripping the ability for a student to be able to really own what they're building. Now, not everybody does this in Scratch. Our teachers do it in iOS. That's a different story. Okay, so what is Computer Science A? So this is the junior, senior level class now. Now we're in our junior year. We're ready for homecoming and our first prom. We're kings of the world and queens of the world. Here are the 6 things that you need to learn about in your Computer Science A class. And remember, this is all in Java. So you learn about the basic oriented design. You learn about program implementation, program analysis, standard data structures, standard operators as algorithms, and computing in context. This should look a little more familiar. Okay? What I want to show you, this one's actually broken down into topics. Not that one. Here we go. And I will zoom in on this. So let me zoom in and go over to a single page. So here you go. So here's program class design. There's object-oriented classes, abstraction, code reuse, functional decomposition, which sounds super fancy. I don't even know what that one means. That's okay. Probably something to do with functional decomposition. Programming implementation, top-down object-oriented encapsulation, procedural abstracts. Here, programming constructs. Now this is probably looking very, very familiar. This is the stuff that we used to start with, right? Constants and variables, classes and methods, text output. Using system dot out dot print. So specific. Method control, sequential execution. Some of this is looking pretty good, right? Looking like something we remember from our own days. De Morgan's Law. I don't even know what is De Morgan's Law? Does someone know?
Yeah.
Yes, tell me what that is.
It's a logic law that states basically the distributed property of a negation.
That's awesome. That definitely belongs in an AP class, right? Especially when you're talking to high school students. Java library classes, testing, debugging, all of these things are great things. We love this, but they don't get this until their senior year, junior or senior year. So this is well after where they have been with Scratch. And then for some students, can you imagine jumping from Scratch to this? That's got to be just incredibly, incredibly difficult. But this is what we have, because this is, again, we don't have enough teachers to teach it. And so we are being driven by what the colleges are telling us needs to be taught. And so one of the things that, when I talked about the fact that it was Java, so there's Java.
one of the issues, and I love this stat, is that there's this belief system from the college system that in order to be a vetted programmer, a real programmer, you have to have a CS degree. How many of you have CS degrees? It's okay.
Great, almost the whole room. How many of you don't? Hey, and that's okay too, right? It is viable to be in this field without a CS degree. You can make a great living. But there's this sense that in order to be a good programmer, you have to know all the theory and all the academia behind it. And we're discovering that that may be true. That's not how we get students to come into class. Goes back to the academic. Oh, this was my analogy. If you start teaching students coding, what we've seen in the past, and this was me about 3 years ago, before I touched coding, they would come up to me and be like, let me explain to you what coding is. You're going to take a variable. I'm like, what's a variable? Like, a variable. You're going to take that. I'm like, I don't know what a variable is. And their like heads would explode. They're like, a variable is something that you assign data to. I'm like, assign? How do you assign data? I don't, why would you do that? Why wouldn't you just leave that poor data alone? Right? And it wasn't until I actually started to build applications and started to dive in, and then someone said, let me walk you through a Hello World app in Xcode. Great. Put a button. Great. Buttons. Get those on the user. Got it. Change the background color. Great. Got that. Let's add a text box. Awesome. Where are you going to hold the data that's entered into the text box? I'm like, a variable? And they're like, that's right. It's because I didn't have any context to it. And for me, if we start with theory, which is what we don't recommend in a lot of the classes that we work with, it's like trying to teach someone to play piano and having them only listen and study Mozart, but never actually giving them a piano to play on. Where this doesn't make any sense. It's like, no, before they try it. Love it? It's variable. So what am I doing to fix that? Because this was a pain point for me because I saw that we were losing swaths of people to not say computer science was for them. We were losing women, we were losing people of color, we were losing different genders, different sexualities. It became a place that was not us. And so my goal has been to showcase, no, really, it may not be for you, but it's a skill you should really have, or at least have an idea for. And guess what? You can do it. You can absolutely do it. And if you like it, you can get paid for it. And if you get paid for it, you can have someone pay for you to go to college for it. How's that sound? And all of a sudden, it opened up all kinds of doors. So we've been focusing on teaching teachers, number one, to make sure that there's more teachers that are out there. I love you all very dearly, but I have taught coders how to teach, and I've taught teachers how to code. It is worlds easier to teach a teacher how to code than it is to teach a coder how to teach. And I say that with the utmost respect. Teaching is like parenting. There are nuances, and it's exhausting. So it's very difficult to teach someone how to teach. Okay? And maybe that's just my experience. But, so we've been teaching teachers how to code. We've also been taking out the theory, and we actually get them building from day one. So the way that we do that is we help teachers have students build 8 applications over the course of a year, and they start on day 1, and they build the first app and put it on their phone within the first week. So there's that sense of, oh my God, I can do this. And they run home and show their mom, just hit the button, it changes the background color. And the moms always go, why doesn't it turn off? I haven't learned that function yet. Right? It's just, I can just turn it. So, but regardless, we focus on getting them in, and we really treat it like an apprenticeship, where if you are an apprentice for a blacksmith, you don't study metallurgy first. You go and you hammer stuff and you see how things work in fire, and you mess things up and they break and you burn yourself, and then you can understand the chemicals. Oh, well, that's why iron does that. It's because you now have grounding experience. We also focus on educating administrators, as I'm sure after you heard me talk about kind of what's going on. Most time the CS teachers that's in a classroom is the lone wolf. They are the only CS teacher, they're also the math teacher, they're also the IT person, and they're also usually the director of networks. So they do everything. And it's often because they said, oh, you were good with computers, great. Anything computers you can take on. Oh, you know how to use CSS? Great. You're the IT teacher. Okay, so a lot of it is also just helping the administration understand that
The world of CS is now stratified, and there's multiple, it's almost like the world of medicine. There's multiple specialties. Where do you want your students to come out and what skills? We develop coding teachers, and then we talk about, we connect real life developers to schools. And this is one of the reasons that I love talking about what we do, is because the community of iOS developers are hungry to help the next generation of developers. So it's just so much fun to watch our developers get so much joy out of talking to some of the teachers and the students. So the question has become, well, how can you get involved? Or what can you do? There's a variety of things that you can do. You can always work with your local high school to help talk to them about what courses do you have? One of the biggest components that I see work really well is just call your local high schools or check out their list and ask what computer science classes they have. Sometimes they'll go, oh, we've got programming 1. Offer your expertise up. You come to the table with so much expertise. Do not undervalue yourself. Being able to say, you know what, I will give you 30 minutes of my time to sit down with your department heads on curriculum. Let's actually map out a pathway of courses that your students could take. Administrators love that because they don't know the field and they know you. And all of a sudden this becomes like a real world thing. They're not just hearing what's going on in college, but they're hearing what's going on in the workplace. And that is incredibly, incredibly vital. You can also tutor, of course. You can always work with the students directly if you want, although I found it to be, if you're really looking to make a broader change, meet with the administrators first to create that pathway and help them understand that hardware is different than developing software so that they can have some better conversations. And then, of course, we also have opportunities if you are looking to scratch an itch, if you want to volunteer. We do app contests that always need judges. We have students that are looking for virtual tours of classes that are looking for a guest speaker, that's a virtual guest speaker, or a physical if we're in your area. And then, of course, we always do workshops that are online with webinars. So if you have a really cool new thing that you want to show someone, and you want to show someone who's really hungry for it, our teachers are always really excited for it. We've already got a couple teachers that are clamoring, asking for AR kit stuff. And I'm like, well, hold on. let's get you through delegation first. Let's set up a table view and then we'll talk. Okay. So I wanted to keep it super short, so if you wanted to ask questions about, that's my dog. So who doesn't like the picture of my 12-year-old puppy swimming in his therapy session? If you want to learn more, this is a little bit link. You can fill out a quick little form. We'll send you some more information about how you might be able to volunteer, either with the community that we do, or if you are interested in just seeing if there's a school in your area that we know about that is looking for someone. And then you can also email me and contact me on Twitter. But I wanted to leave some time for Q&A if you have questions about why are we only doing AP and why are they including more languages. So I just kind of want to open it up for some questions. See what
I never
yes,
saw
sir.
how much of my talk you saw, because I saw you coming late. Can you talk about what AP stands for?
Yes, sorry. Education is filled with acronyms. I apologize. It stands for Advanced Placement. And AP means that if you take the course and you sit for a test and you get a certain score on the test, you can earn college credit. So there is a huge push for a lot of classes to be AP because college is expensive, and so parents and administrators want students to go in college ready. Schools also get ranked on funding based on how many students sit for an AP class. So there's also that reality as well.
That's at the high school level.
It's a high school level. Yep.
Just more of a comment about things that when I was in high school, they didn't have any programming courses whatsoever. In my particular school, I took anything that was computer related, and that was like word processing. So when I got into college, I was having to learn from the basics. Here's an int, here's an array, versus other people who didn't even have elementary programming courses. At least they had that basic understanding whether it was a different language or not. I know a kid that's in high school at Dennis Grove in the Chicagoland area,
Yes.
and he's already learned some C#. He's learning Python right now. And so like, that's really cool. And I saw, and he showed me a couple of little programs he's run and stuff like that. It's like, oh, that's pretty cool. I wish I had that back in high school.
Yes.
That kind of wraps up your
It does. And there are some schools that nail it right on the head. Like if I could do multiple languages there, it's huge. You mentioned word processing. We still have teachers to this day who consider themselves CS teachers because they teach Microsoft Office. The differences are so great between different levels of school. We have some schools that their entire focus is on tech, and they have 7 computer science teachers, and they're bigger than the math department. So it just depends on what your area values and what your school is willing to put into that. So that's why I'm a huge proponent of the local community coming forward, so like going to your local schools and saying, knock, knock, hey, I'm here, I've got some expertise, let me help you figure out how you can incorporate this into your classroom.
Do you notice any different like areas of applications or programs that the high schoolers tend to gravitate towards? Like, is it games? Is it AR? Is it chatting?
It's a great question. Games are a huge hit, but I think that based on our experience, it's because that's what they know. And so they haven't really been exposed. I mean, when you think about all of the apps that are out there right now, the majority of them are designed to solve adult problems. And a lot of students don't have the skill set to solve their own problems yet. So what we've discovered is they will come in with the idea of, I'm going to build the next Flappy Birds. I'm going to make millions. We're like, well, that time is gone. So let's just focus on getting a job. But the idea is once they start to realize that they can problem solve, and that's how we really come at it, like, especially with our curriculum, and our focus is always what problem are you solving? How are you making the world a better place? Which is key to getting young women involved in the computer science classes. If you focus on how are you impacting the immediate community, women's frontal lobes are developed a little bit faster at that age than men's, and so they're actually thinking about that stuff early on. It has to do with the fact that we can have children at certain ages. It's just biologically how we are focused. But once they understand that they have this toolkit where they're like, I have all these Lego pieces, what can I build? But they start to build problems or some solutions to problems we didn't even know they had. So my favorite example is a gentleman who built, he was in the theater department. Yay, computer science theater department, crossover, love it. So he was in the theater department and got really frustrated with the fact that in order to see the results of the casting, he had to march himself down to the cafeteria and stand in front of God and their brother and check whether or not he got a part. And he said, this is so traumatic for teenagers. He's like, this is ridiculous. We need to solve this. And initially, when I heard this, and I'm like, well, what's wrong with that? That's what I did in my day. And then I immediately went, oh, Jessi. Oh, get off my lawn comment. Oh, shame on me. So I made it, then I turned around and I said, of course it had to be changed because that's how it was in my day. And I said, what was your solution? So he created an app that housed everything in, actually I think he just threw everything in spreadsheets to just pull from. And had a student login, had a director login, so the director could log in and fill out all of the times he integrated his school's Google API in the calendar so they could schedule the auditions, students could come in and reserve their spots. Everything was done in the app. When the audition happened, the director could take notes, immediately say, yes, I want a callback. And when he was done, they could say, distribute, and you would get a notification on your device on if you got a callback or if you did not. And then the same thing happened again during casting. And then they created this huge database of all of the students, and he kept adding on to it. So now the school had a running list and a database they could pull from and say, you know, Johnny's been in the lead role every fall. Like, maybe we need to cycle someone else in. And so now they were making better choices about their casting. And it became suddenly a cool thing to do was to audition because it was no longer terrifying to the students. It added a level of, let me say, it's a cool app. But he was solving his own problem. And I think that that was really, really, really powerful for what we got to see. And I mean, we've seen other apps that have done something similar. So we've seen everything from bell schedules, which you wouldn't think are complicated, but anyone who's worked in the education, there's like a new bell schedule every day. So bell schedule apps being able to work to converting like empirical to metric. We've had students create language apps for younger siblings who are dyslexic. Like, we're just having all of these apps suddenly built that are solving these problems of the student directly in front of them. And I think that's the coolest thing, because I think that will start a new trend away from things like gaming, which is, there's nothing wrong with gaming, I think that's great. But if we're really trying to empower the students, what are they doing to improve themselves and hold their own? Yeah.
You mentioned Swift. I mean, do you actually have a curriculum? I mean, so is it all kind of Apple device based?
It is. It's all Swift, and we had a choice when we before we became an Apple professional learning provider, I hate to say that, we're an Apple professional learning provider. Before we did that, we had a choice. And we were looking at all of them. So we were looking at Objective-C, that's what it was at the time. Objective-C, Python, PHP, JavaScript, and Java. And we were looking at all of them. And we had a boatload of criteria. And some of the high-level pieces from that were, it had to be easily understood by the students. So easy entry point. Could not be a block-based coding. It had to be real language. It had to scale large enough to be able to support your best student, but simple enough to be able to support your struggling student. So that narrowed it down quite a bit. And so then we were looking at Python, Objective-C, which I don't know how Objective-C even made that cut, but somehow it made that. It was probably because that's what we were teaching the adults, and someone was, lobbying for it.
Yeah.
We're all victims of our own devices, right? And then JavaScript was the other one. And we ultimately ended up with Swift, because when Swift came out, we evaluated it, we're like, oh, it was just like this moment of, it hits all of the criteria, even though it changes every 3 days. And the story is actually a great story. So we were teaching Objective-C to adults, and we were really excited about doing something with the high schools, and WC 14 happened, and all of a sudden they're like, we're providing a new language. We were like, what? So the decision to actually teach Swift happened over a beer in a local tavern where we were like, what do we do? And we looked at our criteria, and it was like, it just matched. So yes, we decided to go with Swift because when we wanted to create something that was an intro-level class that got students really excited about tech and being able to be excited about coding. And we have never decided to push out and be like, everyone needs to be a coder. That's not our mission. There are 3 missions to our course. You get out of our course and you say, I love this, I want more. You get out of our course and you say, God help me, I never want to touch it again. And the third one being, I don't ever want to touch it again, but I'm glad I have it. And any one of those 3 is okay, because you've been exposed to it, and that you have an opinion about it. It's the vacuum of ignorance we're trying to avoid. So we decided to go with Swift because in that entry point, first teaching someone coding who's never had any of that, it's kind of like teaching poetry. This is the analogy I use all the time, where it's like poetry. And you don't start someone with free verse. You don't start with someone that has no constraints on it whatsoever. And so we needed something that was very tightly constrained. And so Swift was perfect. It was like a sonnet. It was just like, you can't deviate from this. And if you try, Xcode will tell you it's not possible to do. So we needed something really, really, really structured, but that could blossom and be able to do whatever we wanted with it. And Swift has become that, and we kind of forecast, we took the risk, we forecasted out that was what was going to happen basically. So that's why we ended up going with Swift. Does that answer your question?
I think that, there's, especially with playgrounds, it helps you be able to go in and do some small things versus you think about even your simple Java program. Still have a couple lines of various other things you have to put together before you can say hello world.
Yes. Yes, very true. We actually don't start with playgrounds. We start with Xcode. We throw it into the deep end. And that's because our students start as users, and the interface builder is God to them. Like because they can look at it and say, oh, I recognize this. And the moment you show them the object library, it's all of a sudden they're like, yes, 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 yes. And you're like, great, look it up to code. And they go, like, well, let's strip everything down except for a button. And then you start small and you start to connect things out. So playgrounds, we've discovered, is really great for what we call digital worksheets if we want them to start practicing algorithm and functions and things like that. But we don't start there because they're not interactive enough. They don't start with the interface builder. We have seen this bell curve of the playgrounds where when you're first starting to learn, they don't make a whole lot of sense. Then when you just get to variables and constants and functions, then they start to get interesting again. But then once you get past that and you're building out like a simple multiply app or even like a MATLABS app, there's this huge curve where it's like, I don't want to do anything in playgrounds because they can't see it. They can't touch it. Now, keep in mind that I'm only speaking about high school students here. So I'm not talking about doing like reverse binary trees. Like they're doing very, very simple apps. They're doing tic-tac-toe, that kind of stuff. So to be able to see it and be able to see how it reacts when you run it in an actual device is really powerful for them. There are some students who just go to town on playgrounds and they just build everything out as much as they can on playgrounds because that's just how they're wired and that's how they want to think. So we support that too. I mean, there's just, everybody learns differently. So you gotta kind of figure out what's gonna work for the student. Yes, blue shirt, and then I see you back. Yes.
So I don't know what it's like today, but the university I went to, the CS program is very math-based,
Yes.
heavily math-based. Of the high school students graduating and going into CS programs that are heavily math-based, what kind of a dropout rate is there?
Great question. So to get into a CS degree class, even to like be accepted as a student to study CS, you have to meet certain math requirements. So if you want to go that route, yes, you'll have to meet some of those math requirements. The specific CS rate, I don't know, but I do know the global rate. And the global rate for drop-off is there are only 25% of people that enter college that actually stay after their first year. That's it. And 25% of that actually make it to graduation. So the dropout rate in college is significantly high. And it has very little to do with academic rigor. It has to do with cost. It's just too expensive. It's just too expensive. And the demands of more multi-generational families are requiring other things. Some people are opting to do technical schools. There's just different options. And so the dropout rate is very, very high. But I don't think that that has necessarily to do for, like when I'm looking specifically at CS, I don't think that has to do necessarily with the math requirement because to even get in, you have to have certain math requirement.
Right.
But I could be wrong. I could be wrong. I'm not as versed in that.
I'm judging based on my experience. I got accepted in the school. I took all my prerequisites, and then I had to apply to a specific college.
Yes.
And that's when I had to have all of that. And I know several people that are from, they're like all about CS, and it's all the math. And they said, I don't want to do top 3. So they went to CIS and went to more business route.
You know, I've seen some schools and some students do that too, and I don't necessarily think one, like, when we talk about our program, here, let me frame it a little differently, because I'm not as well versed in the higher education space with how CS works. But what we have always tried to do is to create an opportunity for students, regardless of which direction they want to go afterwards. So if they wanted to go into the computer science degree route, that they would have set themselves up to be successful in those math classes that are required. Again, it goes back to that algorithm basing. A great example is an array. When we teach tic-tac-toes, we don't teach arrays. We make them build them out if statements. And that, yeah, I know, right? Well, we're mean. And then we teach them arrays. And it's only then that they go, oh my God, arrays are amazing. And they would not have had that if they didn't have the context for really understanding the power of an array. We've taught it both ways, and it's just so, they just pick up on it so much faster if they have context. But to your point, being able to set them up for that college route, which is, we've designed a class so that I can feed into any of the AP classes, including just skipping the principles and going straight into Java. That we also then do, we see ourselves sitting a lot in what is known as CTE in high school, which is career technical education. So people that take 2 or 3 years of a programming class and then go off and actually work as a developer as opposed to going straight to college. And we've seen other people actually go the entrepreneurship route, which is probably what it sounds like you're more going, which is like the business route of computer science. It's a little bit different. So that's what we've seen. And yes, I do agree with you that we have had some students who have like taken the next level of math because they think they want to go into computer science and discover they don't actually want to go into computer science, they just want to develop, which is slightly different.
Yeah,
I think
that was a big thing for me as I took computer science, thinking, I'm going to program. No, I knew how to compute. I knew the theory behind it.
Yep. We saw that a ton at Mobile Makers. That's one of the reasons the academy started for the adults. Was there was a dev shop in Chicago that couldn't hire iOS developers. And they hired some recent CS grads and they couldn't code. They had no idea how to actually build out. So that was one of the reasons that we came about. And there is, like I said, Steve, the world of computer science is stratifying. You could make very good living being a debugger for the rest of your life.
or doing UX. Maybe you don't have to build. Maybe you want to do something different with that skill set, doing UX and UI or something different.
Yeah, I think it also depends on where computer science was birthed from in that particular school, because some, especially when it was fairly new versus you think about physics, which has been around for a very long time in university settings, that when CS first came, really started to form a lot of places that we're not quite sure where to put this. One of my professors put it, computer science is the bastard child between mathematics and electrical engineering.
Yep.
So someone may be in the math department, some may be in arts and architecture, and then some like, okay, you're sort of engineering. Kind of smash you somewhere.
I graduated with a minor in math and physics.
Most, there are some schools that will plant it, it's often in business because they're trying to do staff augmentation with their teachers. They have a business teacher that doesn't have enough course load to keep them full time. So they'll put it in the business section and just ask them to teach. We've also seen it in the social studies department. So it goes back to where does it sit in school? What does it count for? Yes, sir.
You briefly mentioned playgrounds.
Yep.
Have you seen or integrated any use of the iPad playgrounds at all?
We have the iPad one. We do. We love it. We think it's great. We actually teach our teachers how to build their own playgrounds so that they can distribute them out to their students if they want. We do show them. Apple comes with a ton of curriculum. I should rephrase that. Apple has an amazing textbook that has a ton of resources in Swift Playgrounds, and they do have a curriculum that's built kind of around it. It's not enough to just like plug and play, which is why we come into it, but that material is superb, and that works a lot like the playground. So yes, we use it as a learning platform, but at the end of it, we start there, but then we just always circle back to Xcode. And I've had some really great conversations with some of the Apple engineers, system engineers, and one of them said, you throw them into Xcode, but Xcode has sharp edges. And I'm like, Xcode also has an undo button. I'm like, and the students are totally unafraid to break it because you guys built it really well. You can't break Xcode. You can break your app, but you can't break Xcode. So I think that some of it comes down to also just that what did I learn versus what is best for the students at that time. Yes, ma'am.
First, I think it's really good that you guys do have like a trade track because I feel like that's really important because, like you said, and like many of us in this room know, you don't have to go to college to be a successful software engineer or developer or anything you want to call it. So I think that's really good to expose kids that it's like you don't have to go to college. There are other options. And secondly, I have a question about like, so because we're all iOS developers, we're talking about Swift and everything, that requires Apple to be in the classroom, like Apple products. And I was wondering, especially because I know all of the bureaucratic paperwork and everything that goes with the bureaucracy of public education, what do you think are like the biggest hurdles that Apple faces of getting into the classroom, and what can they do better to like be in more classrooms and be more widespread, especially in public education?
Great question. And I'll answer this, and then if there's one more, we'll take it. I'm just going to be cognizant of time. So my perspective is that Chromebooks did a better marketing job. And they are all over the space because they were promised to be the laptops that were super cheap. And 2 years into it, they are now discovering that you get what you pay for. And one of the biggest hurdles is the cost. And the way that we have worked around it, if you go back to your own schools and have conversations, there's two things that we talk about. One, it's unhealthy for a student to only ever be exposed to one type of platform, period. So even if you are an all-Mac school, you better have some PC somewhere around. It's only healthy for them to be exposed. And two, always, always, always choose platforms that are actually used in the marketplace. And no one uses a Google Chromebook in business. So that's the conversation we typically have. And we also recognize too that we say do it in a rollout. Use your design lab that has iMacs that are really old, but you can use them. And then next year, buy a mobile cart of 30 computers. And then the year after that, start thinking about iPads and thinking about a refresh cycle for all of your IT. That's usually the conversation that we Okay, one more comment and then
I actually want to
yes.
make a comment on that. So I'm on the technology advisory board for my kids' grade school,
Yes.
and they have lots of Chromebooks. And for a private grade school that doesn't have a lot of money, that, oh, we can get a cart of 30 Chromebooks for cheap is a huge advantage for Chromebooks.
Yes.
You know, they might fall apart in a couple of years. And so trying to sell them on iPads it's a hard sell from cost perspective, but the teachers that use Apple devices know how great it is to use an iPad. But even so, I'm kind of on the losing end of that battle. And part of it is also that they want kids, and kids are using a keyboard-based device at like second grade now. And so for them, a Chromebook is a easy entry level into getting lots and lots of devices in front of kids.
Yes.
And so it's very difficult to do that. And I'm like right now working with them to try and change that.
We tend to suggest to start with one mobile cart, and I get looks like I'm crazy when I'm saying you need a mobile cart for your coding class, and because they're in their mind, it's some. I'm going to be very stereotypical for a moment. Some white dude in his mom's basement, right? Coding with Doritos and Mountain Dew alone, and that's not at all what coding is. Coding is so collaborative, and it is so communicative. It relies on so much creativity and collaboration and communication that stereotype died years ago, like years and years and years ago. But there's such this belief system, and so we often say, we'll get a mobile app because there's nothing better than just saying, hey, can you look at my code? I'm confused. And only just do 20 cart, just do 20, that's all you need. Don't do the whole class, don't do the whole, kit and caboodle. Just do this one little mobile cart, and that spreads like wildfire, because now every teacher wants that cart. And it becomes, you get the teacher's buy-in. And there's now questions from the English department and the design department. And there's all these inquiries for more different devices than the Chromebook. So that's what we've seen work. And let's chat a little bit afterwards, because there's lots of grant money out there too for stuff like this. Great question. Okay. I am over my time, so I really appreciate you sticking around. Thank you so much for coming.